All right, today's lecture is confidence interval for the mean. Confidence interval for mean. But what makes it different from last lecture is this time we don't know sigma. So sigma unknown. Okay? So one of the things that you're going to have to be really good at is reading a problem and knowing, are they giving you a population standard mean or are they not giving it to you? Okay? If they are, then you're going to use the z interval that we did last time. If they're not, you're going to do what's today's material, which is on the t interval. Okay? I'm going to go ahead and put the formula up right away, but then we're going to spend some time talking about the t distribution. So here's what this formula looks like. I want you to see how similar it is to last time. So instead of x bar minus z sub alpha over 2, it's x bar minus t sub alpha over 2. Okay? Then times s divided by square root of n. If you look at last time's formula, we had sigma here. But now we don't know sigma, so it doesn't make sense to have sigma in the formula if you don't know it. Okay? So what we'll have in place is s, which comes from the sample, which is usually what happens more often. Comma, x bar plus t sub alpha over 2 times s divided by square root of n. All right, so what you hopefully can see is it's still the same thing we did last time. We have 4 numbers that we need. We need x bar. Instead of z sub alpha over 2, we need t sub alpha over 2. We need to know what s is, and we need to know what n is. Okay, so it's very similar to last lecture in the way that we attack the problem. Okay? All right, so let's spend a little bit of time working with this guy, t sub alpha over 2. Okay? So a couple of things. We need to talk a little bit about the t distribution. So instead of the z distribution, this is the t distribution. Okay? One of the big differences, and the main difference is with the standard normal distribution, the z distribution, there's just one curve. And that one curve works with everything. Okay? With the t distribution, this is called a family of curves distribution. So there's not just one curve with the t distribution. There's many of curves. Okay? It's called a family of curves distribution. So depending on your sample size, you're going to have a different curve to look at. So when we're looking up t values, we have to go to our chart, and then we're going to have to go down to a particular value. Okay? The t distribution is smooth, it is continuous, it is symmetric, it has all of those things that the z distribution has. One thing that is different is the variance, or the standard deviation, is larger than 1, right? With the standard normal, the mean is 0, standard deviation is 1. With the t distribution, the mean is 0, but the standard deviation is larger than 1, okay? And then there's this thing that's totally new to us, and it's called df. And what df stands for is degrees of freedom, okay? When you're working with the t distribution, you need to know what the df, the degrees of freedom, is. Okay? So each time we're working with the t distribution, you're going to be given a formula for the degrees of freedom. For this problem that we're going to do, the degrees of freedom is simple. It's just n minus 1. Okay? And what is n usually representative of? Yeah, it's a sample size, right? Or how many things that we have. Okay? All right, so go ahead and get out your t distribution chart, and we want to start getting used to using it. All right? So I'm going to give a couple of example problems just utilizing the chart. So example number 1, I want you to find t sub alpha over 2 for a 99% confidence interval. I'm sorry, a 98% confidence interval. 98% confidence interval. And the sample size, n, is 15. Okay? So that's the first example we want to do. We want to find t sub alpha over 2 for a 98% confidence interval where n is 15. Okay, so look at your t distribution chart. Now, what is really, really nice about this is if you look at the very top row, it says confidence interval. Okay? So it's really hard to mess that up. Is everybody with me? So they have 80%, 90%, 95, 98, and 99. Well, I've specifically asked you for a 98% confidence interval. So you just have to go over to the 98%. Okay? Now, if you're going down the left column, notice the labeling of the left column is DF, which is exactly what I was talking about a minute ago, degrees of freedom. Okay? So if n is 15, what is my degrees of freedom for this problem? 14. Great. So you're going to go down to 14 degrees of freedom, together with 98% confidence interval, and reading that value, that is your positive t sub alpha over 2 value. So it's 2.624. So everybody see that?
Mm-hmm.
So for this problem, t sub alpha over 2 is 2.2, what did I say? 624?
Yes.
2.624. Okay. All right. So the picture that we have is very similar to z. We have t sub alpha over 2 at 2.624, but you also have on the left side negative t sub alpha over 2, which would be negative 2.624. So the picture looks the same, okay? But actually, it's easier to look up the t value, right? Because you don't have to figure out the area. You just have to go to the correct confidence interval level. And for a quiz or test, I'm only going to ask ones that are actually on the chart, so you don't have to worry about other ones. Okay? All right, let's do another one. Let's do t sub alpha over 2. Let's do 95% confidence. So example 2. Let's do 95% confidence. Let's do sample size is 22, n is 22. And I want to know what the t sub alpha over 2 value is. Okay, so 95% confidence. N is 22, which means my degrees of freedom is 21, and you should get what?
2.080.
2.080. Great. 2.080. Okay, so not too difficult so far, and it's really not that bad to do these problems. Let's do one more example where you could run into some weirdness, and let's do a 99% confidence level, and let me give you n equals 60, okay? And then I want you to notice what happens here. So when you go to your chart, what is the degrees of freedom for this problem? 59, okay? In the first two examples, our degrees of freedom was in there. In this example, is the degrees of freedom in there?
No.
No, it's not. Does everybody see that? There's a gap between 55 and 60, okay? So if you run into that issue where your degrees of freedom is not in the chart, you go to the closest smaller value, okay? So please put that in your notes. You go to the closest smaller value, okay? So I will go to 55, because that's the closest smaller value, and then I'll go to 99%, and your t sub alpha over 2 will be 2.668. Always the closest smaller value if it's not in there, okay? So highlight that in your notes because that will happen. Okay, let's do an example. Okay, a group of 10 men were subjected to a stress situation. The mean number of heartbeats per minute was 126, and their standard deviation was 4. Okay, so example 1, we have a group of 10 men. They were subjected to some stress test, some stress situation, and the findings were a mean number of heartbeats per minute of 126. So mean number of heartbeats per minute. And a standard deviation of 4. And it simply states, find the confidence interval, find the 95% confidence interval for the true mean. Okay. So this sentence here is going to tell us everything. All right? And the question that we need to know, obviously we're doing a confidence interval for the mean, because it says in the problem, you know, what's a confidence interval for the mean, okay? So really you have two choices. Is it last time's lecture or is it today's lecture, okay? And that's completely based on the standard deviation. So it says the mean number of heartbeats per minute was 126 and the standard deviation was 4. So the question to you is that coming from the sample or is that coming from some perceived population, okay? Hopefully if you read this, there's a group of 10 guys that did a stress test, the mean number of heartbeats was 126 and the standard deviation was 4. It seems pretty clear that that's coming from the sample. Does everybody agree with that? It doesn't say, oh, from past studies it's known to be 4, or oh, we happen to have the population standard deviation and it's known to be 4, okay? It literally would have to state that to do last time's lecture, okay? So this is clearly today's lecture. So here's what we have so far. We have n is 10. We have x bar is 126. We have s, that is clearly s, is 4, okay? You have 3 of the 4 values you need to solve this problem. What's the only other thing that you have to get real fast? T sub alpha over 2. Okay? What's the degrees of freedom on this problem?
95.
Degrees of freedom is?
9.
Yeah, 10 minus 1 or 9. Okay, so I'm going to give you guys a minute or two. Find T sub alpha over 2, plug it into the formula, and then you can double check it with, well, I'll do it as well, and double check it with me. Okay? It's the same thing over and over and over. Yeah, you should get 2.262 for your T sub alpha over 2. And then it's just a matter of can you plug it into the formula correctly. And let's go ahead and go 4 decimal places here. So I'm getting about 123.1388. 123.1388. Comma. And then the other side. $128.8612. Okay? So again, what we're saying is with 95% confidence, we believe the true population mean is somewhere in between these values, 123 to 128, something. Okay? That's pretty much it. All of these problems will be worked almost identical. Okay? So just be on the lookout for, is this coming from this sample? If so, it's today's material. Okay. Also, one little thing that I should say, if the sample size is less than 30, somewhere in the problem it should say, assume this is normally distributed. If the sample size is 30 or more, it doesn't have to say that. Okay. But that will be clear in the problems in the homework and stuff. All right, great. Let's review what's coming up on your next exam. Okay, so this starts with counting techniques. All right, things that are definitely on your next exam with counting techniques. You're going to have to know when to use your rules. When to use n factorial, when to use NPR, when to use NCR, okay? Combination, permutation, when does order matter, when does order not matter. We definitely are going to have some ID card problems on there. Okay? So go back in your notes and homework and make sure you're really good with combination versus permutation. When are you just using multiplication rules for counting techniques, okay? The ID card problems, you know, it's like, okay, we know we're multiplying. How many do I have available for here? Am I allowed to repeat? Am I not allowed to repeat? That'll tell me how many I have left here, how many I have left here, okay? So, yeah, counting techniques. All right, what was after counting techniques? What was the very next major thing we did?
Kind of distribution.
Yeah, probability distributions, right? So you will have probability distributions on there. What is a probability distribution?
The little.
It's basically a table, right? Where you have x and p of x.
There's a formula that goes.
You have some values, and what does the sum of the px have to add up to? 1, right? So I could just make up one real fast. 2 has a 0.8 chance of happening. 3 has a 0.1 chance of happening. 4 has a 0.1 chance of happening. There you go. I just made up a probability distribution. Okay? We looked at the probability distribution, and then we looked at finding what we called the mean and the variance and the standard deviation of a probability distribution. These are all formulas, okay? And they're not the best formulas when we first did this, right? So the mean, you have to go through each x times p of x plus x times p of x plus x times p of x, right? For the variance, it was x squared times p of x plus x squared times p of x plus x squared times p of x minus the mean squared, okay? And then the standard deviation, of course, was the square root of that. In this section, we did some game problems, right? So be ready for those. I will say find the expectation of the game. Is the game fair? Okay? That's definitely going to be on your next test. Moving on, we got to, what was the next major thing?
Binomial distribution.
That's right, binomial distribution. Great. Binomial distribution. So you need to be able to identify quickly, oh, this is a binomial distribution problem, okay? Once I've identified that, I have to look up some things really fast. I need to know, okay, what's n, what's p, what's q, and what x values am I looking for, okay? N is the number of trials, okay? Or if it's a sample, how many people in the sample. P is the individual probability of success. That doesn't change, okay? If I flip a coin 100 times, the p is still 0.5, right? Not going to change. Q is the complement of p, so 1 minus p. X, this is huge, all right? Am I doing at least 3? Am I doing between 5 and 10? Am I doing at most 2? Am I doing exactly 6? I could ask you a million different ways what x is, okay? So you need to know, is it exactly 3? Or is it at most 10? Or is it less than? Or is it in between? And you've seen that on your labs as well, okay? Also be comfortable with your calculator. How do I figure out the x's that I want using my binom CDF, okay? The best thing, though, is these guys here are really easy when you get to the binomial distribution. Instead of having to go through that horrendous formula, it's just the mean is n times p. The variance is just npq, and the standard deviation is just square root of npq. So this is a great thing about the binomial distribution, okay? And so I have problems down there on find the variance from this binomial probability distribution. All right, what was the big main thing after binomial? Yeah, the normal distribution, right? So we go from binomial distribution to normal distribution. Okay? The first thing that we did with normal distribution, finding area. And that is definitely on the test. I can't stress, any picture I give you, you need to be able to find the area, okay? That quickly turns into a probability. So after area becomes a probability, z is greater than 2.52, okay? It's the same thing. That just means find the area to the right of z equals 2.52, okay? So you have finding area, which turns into a probability. Then you had three major things with normal distribution. We had what I termed regular normal distribution. What was the next one?
CLT?
CLT, that's right. And what was the next one?
So approximation.
Normal approximation. Okay. All of these are on your test for sure. And you have to make sure you know which one is which, because they all look pretty similar, okay? Regular normal distribution. They say, hey, you're dealing with the normal distribution. Here's the mean. Here's your standard deviation. One is selected. What's the probability that one individual thing being selected is greater than 2.6? That's regular normal, okay? CLT, you have a class of 40. What's the probability the mean of that class is greater than 3.1 or something, okay? So you're looking for this mean of sample. That comes up all the time with a CLT problem. These problems are work virtually the same. What is the only difference when you do the CLT problem? What do you have to do?
Different standard deviation.
Yeah, what's the standard deviation?
It's like
It's
a
the original standard deviation divided by,
square root of n.
yeah, square root of n. Good. Normal approximation is a binomial distribution problem with huge numbers that we can't do, so we use normal approximation to do it, okay? You need to know the mean, you need to know the standard deviation, and probably the most important thing that people forget is CC, which stands for continuity correction, right? Make sure to apply the correct continuity correction. Do I add 0.5? Do I subtract 0.5? What am I looking to get? Okay, then after normal distribution, that was a big section. We just had two more things. We did z interval for the mean. Sigma known versus t interval for the mean. Sigma unknown. Okay, and we had one more thing in this section. You also had minimum sample size needed formula. So go back and look at that. That could easily be on there too. Minimum sample size needed formula. Okay, that's it. So I say that's it, but that's a lot of stuff, all right? You have to go back and get comfortable with all of these things, all the way from counting techniques up to today's material, which is t interval for the mean, okay? Print out your practice exam, obviously, do the practice exam. For this test, you're allowed 1 4x6, both sides, and next card.
Next.
Both sides.
What is this?
Okay? Obviously, your homework will be due. Any questions on the test coming up on Friday? Okay, great.